Hi, I'm Steve Horvath, studying at the University of California, Santa Cruz, Silicon Valley, and this video is my final project for the Object-Oriented Analysis and Design course from Professor Edwin Mach. So what we're going to demonstrate is some principles of design and development of object-oriented concepts, and hopefully demonstrate this video program that you're seeing here, which is called Alien Invasion. So let's get started. So before I jump right into the demonstrating the gameplay of the program, I would like to go over some of the architectural decisions and diagrams that were created for presentation of this fun little program that I wrote. I might also add that I probably spent more time than I needed to programming, but because it was a game and I was having so much fun in developing it and playing it and refining it and improving it, it turned out to be more hours of work probably than I really needed to, but because it was fun I really enjoyed it, which is good, right? Because it means that I'm learning more. So the program or the game follows a model that was an idea that was invented a few years ago called the Model View Controller, or more commonly known as just MVC. In the MVC architecture, we have, as you can see on the screen here, we have the model, the controller, and the view. In the view is the space that the user interfaces with. So in the view would include the display and or sounds that the program might produce, as well as any buttons, a mouse movement, keyboard action, anything that the end user would interface with would be in the view object. However, the view does not do anything that involves directly with the calculation of the gameplay. All the math is done over here in the model. In the model, we have things that are calculated, like the position of spacecrafts, collision detection between objects, all the things that the program needs to keep track of and follow. But the model doesn't know anything about what the view looks like. All it is taking input from the view and things like, I clicked my mouse here, or I want to build a city there, or what have you. It does a calculation based on its model, and then once it decides where the next clock tick is, it sends that information back to the view where it can be displayed. But the view doesn't even know, the model doesn't even know that the view exists. The model's sole purpose is to do the math or the calculations in the underlying model. The user never sees any aspect of the model. That is sort of the magic that happens beneath the covers. The controller in the middle is the mediator for the interface between the view and the model. Now, there are different ways that the controller's been implemented in different MVC models. There's different incantations. In some cases, the controller is a mediator both for the actions that go from the view to the model, as well as the model back to the view. In this program, I chose not to use the controller, but to have a direct sending interface from the model to the view for the output. This is one possible incantation of an MVC model. It's not the only way it can be done. The view is collecting button clicks and mouse clicks, and we don't necessarily want to overwhelm the model with the handling of mouses and all that. So we have the controller in the middle that listens, is a listener, a Java action listener, that listens to the view and collects any actions that the view is doing. It's sitting on objects that can be detected, like mouse clicks and buttons and all that. That controller will listen to the view, collect up those actions, and then send them as a nifty call by invoking a method in the model, telling it that, hey, a mouse click was at X and Y. It doesn't say, hey, it was you know, what it's specifically what it does, but only that the mouse clicked at a specific location. There's one other aspect, and that is the controller needs to tell it what that mouse action does. So that's all the model gets as input, is, hey, there's a mouse click here, there's a mouse click there. The user wants to take some action in this area, and so act upon that and do your calculations. but it really doesn't know what the user interface looks like or how that input came or where it came from. It just knows that it was passed from the controller into the model, and is somewhere out in the real world some information was passed, but doesn't really know where it came from. That's where the model is abstracted and removed from the user, so it can focus truly on what it's good at. The model then, once it has updated the positions of all the things in the model space and the game space, like the spacecrafts and the bombs and all that, after one clock tick, it will send that information back to the view, where the view is an observer and can collect that packet or that object of data. Now, I might add that I said earlier the model doesn't really know that the view exists. What I'm using is a Java utility object called an observable. So in other words, the model sits there and it presents the data as an object out to whoever wants to see it, but it doesn't really know where it's going. So when it's done doing its calculation, we use this observable model that says, hey, here's a structure of, or an object of various variables, things like there's a spaceship at point A, there's a city at point B, you know, whatever. This is what it looks like, not what it looks like, but where it is in the game space, and then it makes it available to any object that has instantiated the observer or has extended the observer utility from the Java framework, so or JFrame framework. So in this way, the model says that here it is, and any view that comes along can grab that's extended the observer view. So because of that, we could actually have multiple views, and that's the beauty of this system, is that we could, and we'll demonstrate this later, where the model doesn't really care how many views there are. It's just saying, here's the data, whoever wants to grab it can grab it. So this way we've completely abstracted the model and the view from each other. They're completely disconnected. There's a very tidy API of how data is passed back and forth between these two objects, but there's no complicated spaghetti or interleaving between the two objects to make it all work nice. And you can see that in this way, in the view, I can do things like determine what a spaceship looks like, or what a bomb looks like, or what color it is, or any of that, and the model doesn't care. It just says, hey, it's at the point X, Y, you draw it however you want. That's not my business. And so I can instantiate different views, and I'm going to show later that I have a simple view and a more complicated view, and I even have an ASCII view that I'm going to demonstrate here in a few minutes that shows that in ASCII representation, the information that's passed the model. And that's one of the beauties of this MVC model, is that we can grab that data from the model in a lot of different ways, and it doesn't impact the way that the model works, performs, or functions. In the game, we have three actors that the end user can relate to, that appear on the screen. However, although they appear on the screen and rendered on the screen, their actual actions are controlled in the model. Those three objects of interest are called space cities, which are cities that the user, provided he has enough money, that he's built up enough money, he can buy a space city. There are spacecraft, which are the alien spacecrafts, which are trying to attack the cities. And we have space plasma, which is little plasma bombs that the user can instantiate on the screen and put in the path of the spacecraft, and if the plasma gets in the way of the spacecraft, it will actually blow up the spacecraft. All of these things are simple graphical representations on the screen, and so from a view perspective, it makes a lot of sense to have these as extensions of the superclass I call space things, because all of these objects have something in common. So following the principles of object-oriented design, we've created this super class called space things, and all of these objects have an X position on the screen, a Y position on the screen, health, which tells you how good it's doing in the game. So when the health goes to 0, the object dies, and if the health is at 100%, it means it's the healthiest it can be. And in the model, we'll do things like when objects collide, it'll subtract health from the object, you know, and as you can imagine, that's part of the fun of the gameplay, is trying to blow up the spaceships, and essentially what you're doing is you're knocking its health down. That type of thing, okay? So all the space things have this thing in common. So we have a superclass that's extended. However, these objects have a few specific attributes that are not common, and for example, the spacecraft has something called a target X and Y. And I'm not showing all the attributes of all of these, but just to demonstrate the simple principle. But one of the key attributes of the spacecraft is its target X and Y. And target X and Y is the location of the space city that when it's randomly generated during the game, it's going to go attack first. And so the spacecraft will go out, and as soon as it's spawned and created, it will be assigned a target X and Y location, which is the location of the space city of one of the randomly selected space cities that exist, one of these objects, and it will head towards it. If the space city in the process gets destroyed while it's trying to hunt it down, it will then be assigned a new target in X and Y location where a new city. And when all the space cities, when the number of space cities goes to 0, which we keep track of in an array list, then the game is over because all your cities have died and you didn't succeed in winning the game. If you do get through, in this case I've set up 4 waves of attack. If you get through all 4 waves, you will then win the game. So that's basically the object of the game, is to win and to kill all the spacecrafts before they kill all the space cities. In this UML diagram, I'm demonstrating the flow of the program. So the actor or the end user generates mouse click events or button press events, and the mouse click events call the mouse click, invoke the mouse click method onto the controller, which then sends that X and Y location to the model, and the model acts upon that and will create a new space city or a new plasma bomb depending on the mode of the model it's in. The mode is determined also by button press, so the end user will either press plasma or city button on the view, which tells it what the actor wants to do. And that mouse mode is collected by the controller and set as an attribute inside the model. So once the model knows what mode it's in, it'll either create a space city or create a plasma. Most of the time it's creating plasma bombs, because it's trying to blow up spaceships, but occasionally you want to add a new space city. And we'll demonstrate this later in the game on how that works. It's kind of fun. After any new objects or space objects are created, it goes into this computation loop. It will calculate new positions. It will go through all the space objects, determine if there's any collisions, and a variety of other mathematical computations to finally figure out where the final position of each element or object is at the end of this one clock tick. So all the spaceships and space cities, and calculate their health and all the other variables and attributes that they have to determine where they are at in their X and Y location as well. And then we interject a delay loop, because we want this clock tick to be exactly 1/30th of a second. If we were just to do this in an open loop looping function, then when the game gets more complicated, it'll slow down because there's more computation to do. And when the game is simpler, when there's not a lot going on, especially like at the beginning of the game, we may not have, it may be able to get through this computational loop very fast and loop around quickly. So we need to insert this delay loop to get the timing correct for each clock tick. So that this is 1/30th of a second, it will sit here and delay until 1/30th of a second is up, from here to here, and then it will loop back over around and repeat the process. At the end here of the computational loop, it will kick out the graphics. We talked about this earlier with the model. The model will make all of the space things visible as an observable, and any observer class will be able to grab that data and present it and view it however it chooses in the view, and push it out to the monitor so the end user can see that. I'm sure you've been interested and excited to see this game in action for real. We've done so much talking, so without further ado, let's do a quick demonstration on how it works and how it plays. Now, I mentioned earlier that you could have multiple views from the model, and the model doesn't know and doesn't care. And so what I have here is that I've paused the game at the beginning, but what I've shown is this is the main GUI or interface where all the action occurs that you can see. This is one view. I have another view called the debug view. And this debug view is purely ASCII text, and what it does is it represents all the objects that are being passed from the model to the view. And this was very helpful to develop this view, because many times when I was debugging this program, things weren't working right, and while the GUI presents a really nice way for certain types of debugging of certain types of problems, can be really difficult when you're trying to look, when you need the exact math of positions of objects and making sure collision and all these kinds of things are working correctly. So instead I would pause the game and actually refer to the ASCII output, which I could get the exact position of objects to make sure that my program was working correctly, and that when I did have bugs, which I had plenty, that things were just so I could figure out how to get things working the way I intended. So I'm going to start the game now, or take it out of pause, and bring the debug view back up. And you can see, and it's maybe a little hard to see because it's kind of small on the screen, but it shows a space city and a spacecraft, their X and Y location, and their health. And we have one spaceship coming down. Now we have a second spaceship coming down. And you can see over here now that the view is presenting, the debug view is showing 2 spacecrafts and 1 space city. There's also a message, the amount of money, the time, and the score. Right now there is no message on the screen, so the message is blank. But when there are messages on the screen, that will also be passed from the model. You can see now that the first spaceship is getting close to the one city. This one city is for free. That's how the game starts. So that, because when we go to 0 cities, you lose. And we can see right now that the space city's health is at 127. 127 is the maximum health it can have. And after it hits, you'll see that the spaceship dies and the health dropped to 104. Now it's slowly building up again, and but the next spaceship hits, and now the health is down to 85 on the city. So that's kind of how the game works. So we want to stop these guys from attacking, so we're going to drop some plasma bombs here. I'm going to drop in a few plasma bombs here. And you'll notice that they start growing. When they first start, their health is relatively low, and we can see that in the debug view as the space plasma over here. They start at 30 or 40 and they start growing, and as the spaceships hit them, they knock them back down, and in some cases they knock them down enough, they die. And that's basically how the game goes, and I'm just trying to survive here. I can build more cities once I have enough money. I do have enough money, so I could click the city button, create another city over here, put some more bombs over here to protect the city. Maybe I'm going to let this city die just for demonstration purposes, and kind of go through it like that. Okay, now we're into wave 4, and you can see it's quite crazy. So I want to demonstrate that this game is beatable, but it's not easy, and there is some strategy involved, and it takes some experimentation. But basically what we're doing is building plasma bomb on top of plasma bomb to kind of create this wall of impenetrable force. So now we're getting to the very end of wave 4, and as you can see, we were successful at protecting the city. So in this case, our use case says that if you have cities after all the waves have passed, you have won, and there it is. There's your message on the screen that says you win. So I'd like to demonstrate here the idea that you could have multiple views to the model, and the model doesn't really know or care. Early on in the development, the view was not so fancy looking with these spaceships and cities and all that kind of stuff. It was very simple. That's because I really needed to work on the engine of the model, and it didn't really matter what the view worked out. The idea of separating the objects between the model and the view this way worked out very nicely for development, because it allowed me to really focus on the model without having to worry about how it was rendered or how it looked. And so here on the right I have a very simple view, and here I have something very close to the final version of the view. And I can have 2 views, and in fact I have 3 views. I have 2 graphical views and 1 text view of the model, and we could have as many views as we want. It doesn't really matter. They're all receiving the same data but choosing to render them in different ways. And so in this way, when I start the game, or unpause it I should say, you can see that the action is the same, it's just that they look a little different. And again, the model doesn't really care. It's just telling information about where the X and the Y location is. And so you can see on the right here that in the left here the cities shrink when they're hit, but on the right the objects don't really change in shape or anything. They're just doing a simple rendering. And we don't have messages and other things, but it doesn't really matter as far as the model is concerned. In setting that data, if the view would like to consume that data, it can. If it chooses it, it doesn't have to. And this way I could do development on a more simple model. It didn't have to look fancy, and later I could swap in a more elaborate model. And if the more elaborate model for some reason broke the program, I could always go back to the simple model again and see what was different, or if it was something I did in the view or the model or what have you. In retrospect, This project was a lot of fun and I really learned a lot. There were, however, some things that I could have improved upon, and given more time I probably would have made additional improvements, but even still I still tried to follow the object-oriented methodology as much as possible. I'm going to share with you some things where I could have improved upon to make a cleaner design. This application was developed in Java using the Eclipse framework. First of all, here's an example in the model, and it's probably maybe a little hard to see on the screen of the code, but you get the basic idea of where we iterate through all the plasma objects. Part of the overlap and detection is we need to know where the left edge and the right edge and the top and bottom edge of each object is, so we can compare it to the object for the collision. In this case, I do these intermediate calculations where I get the object's width and height and do these calculations to get the left, right, top, and bottom. After I get these intermediate values, then I compare it to the left, top, right, and bottom of the object we're trying to see if there's a collision, and if we do, we add that to our kill list, which is a set in the Java framework, and then we move on to the next one. I realized after developing that I actually calculate these intermediate values every single time I go through this iteration, because each object has a different set, and then when I get to the next spacecraft, I go through and recalculate these intermediate values again. This is inefficient and it has a cost in performance. Although we have plenty of bandwidth in the CPU when running this program, it's not really a big deal, but it's not ideal for a purist point of view for performance. What I should have done is created attributes for these intermediate values, and then at each clock tick recalculate these values and actually store it in the object as an attribute for this plasma bomb. And I could do the same thing for the spaceships and for the cities as well. As we have these intermediate calculations, why not store them in the object itself? Why go through and calculate it over and over again? Would have made a lot of sense, and that would have been a nice little improvement. Another improvement that is in line with object-oriented design is the collection of variables into single objects as they're passed from one entity to another. In this case, the information is passed from the model to the view. I have several types. I have an integer, which is the score, a long, which represents how much money, short, that's how much time has passed in the game, a Boolean type that tells you if the game is over, an array list, which is a list of all the space objects and space things, and a string with the messages. In retrospect, I probably could have lumped all of these together as a single object with several types or attributes and passed from the model to the views a single object as opposed to several observable objects. That would have been all in line with some of the principles of object-oriented design and would have improved the readability of the code as well. And then finally, one other improvement I could have made was in the way that the waves of spaceship come. I've hard-coded that, as you can see here in this message section of the code, where we check for, is it wave time 2, then we send this message at wave time 3, and so forth, and the messages are sent from the waves at the specific time that they occur. And then in this section of code, we actually look at the time and say, hey, is it time to start the next wave? Are we in a gap between the wave? And so we check the game clock to see where we're at, and if we are in a time, then we set this Boolean spawn new to true, and that allows us to go through and spawn new spacecrafts. So what would have been smarter way to improve this is to look at a way of, instead of hard coding each of these game times, is to create an object that represents a wave, and then each wave could have specific attributes that would tell it, how many spaceships are in that wave, and how many, whatever specific or unique about that wave, we could store those as attributes, and then list them in an array, and then release them one at a time. And then this would have been one line of code instead of hard-coded as 4 multiple lines looking for these globals of the intervals. But it's been a great learning, and I really enjoyed this program and this class, and I think I've learned a lot, and I'm really starting to get the idea now how everything is an object really when it comes down to it, and it's just how you want to collect it and present it and encapsulate and abstract it from what you're trying to do, so that you get the things that are repetitive out of the way, so that you can work on the more important parts of the game where the real thought process works. Once again, great class. Wanted to thank my instructor, Edwin Mach, and for this great opportunity, and I really learned a lot. Thanks again.